Did you ever come across these questions about electronics cleaning? Zestron checked these myths scientifically, independently from machine manufacturers, technically well-founded and transparent. Due to the cleaning principle and the chamber geometry of one-chamber batch systems, there always occurs shadowing, which may impact the cleaning results negatively. Where does this statement come from, and what's behind it? To better understand this thought, you need to look at the working principle of batch systems. One-chamber batch systems consist of a cleaning chamber in which the boards to be cleaned are placed in one or more baskets and cleaned and rinsed by several spray arms. In most cases, the spray arms are located above and below the baskets, which means on the floor and the ceiling of the chamber. However, there are also systems with additional arms on the sides to the right and left of the baskets. Depending on the machine configuration, the baskets are fixed and the spray arms are moving. Or the spray arms are rigid while the basket is moving. The throughput, thus the number of cleaned assemblies in a defined period of time, is an important parameter of a system. In one-chamber batch systems, the throughput depends on the placement density in the basket. High density and thus high placement also means higher throughput per batch. The more densely the system is loaded, the higher the probability that the assemblies will cover each other. This phenomenon is called shadowing. Usually, the substrates come into contact with the cleaning agent from above and below, or from two sides. This means that never all directions and angles get covered by the cleaning agent. In addition, it can happen that individual larger components on the PCBA lead to shadowing in specific areas on the board. This would mean that there are always areas on the assembly that experience shadowing, and the cleaning result would be worse in these areas, respectively, that a longer cleaning time would be required to achieve good results. What if this myth was true? Would it mean that there are always shadowing effects on the boards when the machine is fully loaded? That a certain area on an assembly sees less cleaning agent than the rest of the board because it's covered by surrounding assemblies and located in their spray shadow? And if this was true, would it influence the cleaning performance? And could shadowing effects be avoided by different machine configurations? We scientifically checked this myth. We selected a typical batch system with a rigid basket and moving arms, and a system with a moving basket and rigid, non-moving arms, and carried out comparative tests. Both systems are widely used in the industry for lower volume cleaning applications. We have used a glass test board equipped with components of different standoffs and contaminated with a defined test flux in order to test the cleaning performance under components. In a first step, we carried out cleaning tests with so-called empty runs in both systems. For this, we only placed a few of our test boards at different positions in the system. This allowed us to define the cleaning performance without any shadowing risk caused by other substrates. In the second step, we fully loaded both systems, each with two baskets, one on top, one on the bottom, and thus reproduced the usually desired maximum throughput in production. We again positioned our test boards in the same places as during the empty runs and loaded the rest of the baskets with standard boards of the same size to allow for potential shadowing. Several test series were run with both systems empty, only loaded with the test boards, as well as fully loaded with the test boards and other assemblies. To find out whether shadowing actually occurs, the cleaning results under different components on the test boards of the empty runs without any shadowing were compared with the test boards of the fully loaded tests. What were the results? Did the test results prove any shadowing? And if so, what effect did this have on the cleaning results? Could shadowing be avoided with the help of certain system configurations? And which other factors, such as the inclination angle and the board's positioning in the basket, have an influence on the cleaning result? Detailed and scientifically verified answers to these questions and details of the test series can be obtained from one of our cleaning experts. Request the results now.